All right. Well, welcome everyone to Blue Team Con Online. So, as this is the first of our series of conference talks, I wanted to kind of give an overview before we get started. So, what is Blue Team Con? So, it's a Chicago cybersecurity conference for defenders of all types, whether you're in a traditional security role or you're in red teaming or you're a developer or sysadmin, what have you. Um, you know, you can come to Chicago and be able to learn a bunch of these things in person. They're split across many different tracks, and sometimes it's impossible for you to be in two places at once. None of the talks in Chicago are recorded, so sometimes you miss something that you really wanted to be able to see, and the way to be able to see that is through Blue Team Con Online. So in the previous years, what we've done is we did these talks on Discord, and we've heard your feedback, and now we're streaming them on both YouTube and Twitch. So each of the past speakers has the option to be able to rebroadcast their talks. And Omid Mirzai is our first speaker, and we're very excited to have him on today. So I'm going to turn it over to you for your presentation.
Thank you, Cameron. Well, hello, everybody. Thank you for tuning in and for joining us for this first presentation of the online version of Blue Team Con. So I gave this presentation a few months ago in Chicago in September 2025. And right after that, I was approached by people. I got some follow-up questions, and I was asked if I could share the slides. So I thought it could be helpful to give this presentation online again and maybe get some questions at the end. So as you know, this talk will be around CSS abuse in emails. I'll be talking about how attackers, threat actors have used cascading style sheet properties in email threats over the past few months and years. And what are our mitigation options, right? And how we can fortify defenses here. Before I start, let me introduce myself very quickly. I work in the email threat research team at Cisco Talos, and my team is responsible for developing and monitoring customer-facing detection features that block email threats. We also share threat intelligence with security community whenever we find something interesting. So I've been in the cybersecurity domain. I've been working in this domain for more than a decade, starting from cryptography and steganography, then moving to Android security, Android malware detection and characterization, then to Windows malware detection, and then most recently to email security. I hold a bachelor's degree in computer software engineering, a master's in AI, PhD in computer security from Carlos III University of Madrid, and a postdoc in computer security from Northeastern University. I've had a couple of conference and journal papers. I've had several blog posts and most recently a couple of US patents. With that, let's start. So benign technologies and features have always been used by attackers for a wide range of purposes, right? Either it is to deliver malware on desktop computers, or to violate the security and privacy of users on Android devices, or to send spam messages abusing third-party services or platforms. So I'll start with the first two categories. I will give you one or two examples, and then I'll change gears and focus specifically on emails. So living off the land binaries are, binaries that are either pre-installed or native in the operating system, or they are downloaded binaries. So they're not pre-installed, and they are officially provided by the operating system's developer, for example, Microsoft. And these, you can see a few examples here. The first one is an executable that is used to execute Microsoft HTML applications or HTA files, but has also been abused or weaponized to run malicious scripts. The second one is a legitimate tool for managing certificates, but has also been abused to download files from the internet. The third one is used for automation or scripting, but has also been abused to download and execute malicious payloads. And the last one has been used to execute dynamic link libraries, or DLLs. The other important benign technology that has been abused to deliver malware is JavaScript. Now, JavaScript is a powerful and widely used programming language that plays a very important role in enabling dynamic and interactive features on modern websites, right? However, this flexibility and extensive range of capabilities has also been abused. And you can see a few examples here. The first one is dynamic code execution. So JavaScript has access to a wide range of features and functions like eval, function, set timeout, set interval, that allow code to be dynamically constructed and executed. The second one, cross-site scripting, or XSS, is a vulnerability that allows an attacker to inject a malicious JavaScript into a web application, which is then executes in the browser of the target users. And then malicious use of web APIs. JavaScript has access to a wide range of web APIs, including file APIs, WebSocket APIs, and browser notification APIs, and clipboard APIs. So all of these have been abused in the past for malicious purposes. Last but not least, JavaScript has been used for things like social engineering, for creating fake UI elements or manipulating the document object model elements for things like clickjacking, right? In clickjacking, an attacker could add an invisible iframe and then trick the users into clicking on something they didn't intend to. Okay. Now let's move on to Android. One of the benign technologies that has been abused in Android is the intent-based communication system. Now, intents are a fundamental part of the inter-process communication system, which we call it IPC. And what intents do, they allow apps to communicate with each other or with system components, right? Whether it is starting an activity on Android, an activity means a new page, or start broadcasting a message, or other things. Now, we have two types of intents. We have explicit intents, where the target, they target a specific app or component, for example, by launching a specific activity. Or we have implicit intents, where the target app or component is not explicitly mentioned, and you allow the system to determine that the appropriate recipient. So in other words, intents are messages or communications that apps send to each other, and some activities are described in those communications. Now, poorly implemented intent handling can lead to things like intent spoofing, where a malicious app can send fake intents to exploit components of other legitimate apps, right? And intent sniffing, where malicious apps can register to listen to broadcast intents that contain sensitive data. Or if apps include sensitive data in intents without encryption or a proper restriction, that can lead to data leakage. So all of these have been abused in the past in Android. Now, let's move on to permissions. Permissions are a set of privileges that Android apps must request to get access to specific features, data, or hardware on Android devices. Now, location permissions have always been one of the most sensitive, permissions. Android apps may require location permissions to provide functionality that depend on the user's geographical location. And examples include navigation apps, ride-sharing apps, weather apps, social media, and dating apps. However, location permissions have also been abused. One of the examples is tracking the geographical location of users in real time without their consent or over extended periods, right? And therefore creating a geolocation profile for users. Second one is collecting geographical location of users and then selling them to, advertisers, third-party advertisers, or data brokers, or other entities. And these are a few examples of apps that has done this in the past. The other thing that adversaries, bad actors have done is combining location data with other sensitive information on the device, like contacts or messages or browsing history, and therefore creating a comprehensive profile for each user. Now let's move on to email, right? I start with cloud and collaboration platforms because these are still one of the most popular and important platforms, legit platforms that are being abused to deliver, phishing and scam emails. Now, cloud and collaboration platforms, they facilitate remote working. They are widely trusted by various industries, right? And they can scale very well. And that's why they are a popular target for attackers. So they exploit this popularity to deliver, phishing emails or other types of emails. Now let's see what are a few examples of abuse of these cloud and collaboration platforms. One of the things that we have seen attackers do is they host their malicious payloads on these platforms, and then they include a link or URL in emails to these malicious payloads. Therefore not attaching the payload directly in the email. The other thing they have done is creating fake login pages and then and then hosting them on these platforms, and then again including a URL in the email. The third thing is one of the trickiest things they've done is embedding links to malicious websites in PDF files that are hosted in these platforms. And then sometimes those PDF files also include URLs to the final phishing page. So this is tricky. And then the next one is sending direct emails from these platforms. A great example is Adobe e-signature abuse, where attackers have used this platform to directly send emails to to victims and target recipients. And then the last one is using these platforms as a command and control infrastructure to communicate with the malware on the compromised device. The next benign technology that has been abused is email marketing platforms. Now, these are platforms that are used by organizations of all sizes to send legit, legit email campaigns. And these are the most popular ones: MailChimp, SendGrid, MailJet, and MailGun. Now, what we have seen is at least these three cases of abuse of these marketing platforms. One is sending large-scale spam campaigns to overwhelm recipients. Second one is using the analytics features of these platforms for things like reconnaissance. And then the last thing is collecting sensitive data, sometimes credentials, using subscription pages or forms that can be sent from these platforms. The other two important third-party services that have been abused are URL shortening services and bot management services. So URL shortening services, in a legitimate context, they allow people to make URLs shorter, readable. But what we have seen is they're constantly being abused to obfuscate malicious URLs and phishing URLs and use them in emails. We got to be careful about them. And then the next one is bot management services. So what bot management services provide is, for example, things like CAPTCHA. What they do is they prevent pages from being scraped by bots. But what we have seen is they are also being abused by attackers to prevent automation systems reaching to the final phishing page, and therefore detecting phishing and convicting those pages. Now let's focus on HTML and CSS properties, which is the topic of this talk. So CSS properties, in a legitimate context, they are used to control the appearance and layout of content in emails, right? Things like images, text, and other elements in emails. Now, So general use cases of CSS, it's to improve visual appeal, responsiveness, customizing interactivity, and enhancing readability. If you open legitimate emails, sometimes you see different content for different, for example, screen resolutions. However, we have identified these three major categories of abuse using HTML and CSS properties. And these are tracking users' actions and preferences, fingerprinting devices, and malicious content concealment, what we call it as hidden text salting. So I want to briefly explain the first two categories, but I want to particularly focus on the last one, which is hidden text salting or malicious content concealment in emails. So as soon as we started seeing an increase of these cases of abuse using HTML and CSS properties, we started sharing them with the security community using these two blog posts in January 2025 and March 2025. So let's see how users' actions and preferences are tracked using CSS properties, or can be tracked using CSS properties. One of the greatest examples is using media queries in CSS, right? So media queries allow you to adapt content for different types of, for example, schemes, color schemes, or for different actions. For example, you have media print. So using, for example, media prefers color scheme, you can track if the recipient is using a dark color scheme or a light color scheme, and you can have unique URLs to track those things, right? As you can see in this example. Or you could understand when they print emails using another tracking URL. And if you remember earlier, I mentioned that the analytics features of these platforms, of some of these third-party services, are being abused a lot. And what we've seen is this EMLtrack.com, the analytics features are used for such purposes, for understanding how, when users, for example, print emails, or what are their color schemes. So this is one of the platforms that they have used for analytics purposes. Now, how they can fingerprint devices? Well, just by adding one tracking pixel that probably most of you are aware of at the beginning of email, they can get access to a wide range of information, right? So let's see what those information could be. It could be the recipient's approximate geolocation. It could be the email client, the exact email client or operating system, and even device type using this HTTP user agent string or header string. It could be the user's configured language preferences. It could be the media type or media formats that the client supports or accepts. It could be if you want to, understand when that email was opened, you can understand that using that URL, tracking URL that you have embedded in that email. You can understand the precise time and date the email was opened, or you can get the original IP address if that connection was routed through a proxy. So these are just a few examples of great information you can get from the recipients just by including that tracking pixel. Now, let's, like I said, I want to focus particularly on malicious content concealment or hidden text salting. The first question I want to answer is, where can content be really concealed in emails, and what is the attack surface, right? So the first location is pre-header. Pre-header is a section that comes right after the subject. As you can see in the left image, it is open in an email client, so you can see that. And here they have tried to hide something in that pre-header section, and we have here revealed that. And this is a scam email here impersonating Blue Cross Blue Shield. And if you take a look at the HTML source of this email, you can see what CSS properties they have used to hide that content. And you can see the the hidden content here as well. The next attack surface, the next place where attackers have tried to hide content and add irrelevant content to evade detection or to impact other stages of defense pipeline is the body, right? As you could expect. So here you can see a scam email impersonating Wells Fargo brand. And if you look at the HTML source of this email, you can see they have added a fixed pattern of strings in between the words of this email, right? Between the keywords within the body of this email. And if you read it, it is, we've detected some suspicious activity, some blah, blah. So using this technique, they could easily evade detection systems that rely on keywords, for example. I'll explain more about this in the coming slides. But the third attack surface we have seen in use for hidden text salting is attachment, right? So normally they include comments in between base 64 encoded characters to evade detection. In this case, this was a URL, and this URL was base 64 encoded, and they have included this irrelevant comments between these base 64 encoded characters that were stored in an array in this JavaScript to evade detection. Now, so these were the three major attack surfaces we have identified. Now, I want to briefly talk about the techniques that we have seen most popularly being used to conceal content or to hide content in emails. The first one is adding only one or two characters. Here is an example that impersonates Northern Life Lock brand. And if you look at the HTML source of this email, you can see they've added 0 width space characters and 0 width non-joiner characters to evade brand detection and brand impersonation detection, right? The second one, the second technique is adding paragraphs. Instead of adding 1 or 2 characters, adding 1 or 2 paragraphs, large blobs of text for the same purposes. So here is an example that where attackers have included large paragraphs of irrelevant German text in between the content of this email to evade detection. And one interesting technique they have used here is using a combination of different CSS properties. One is using clip property, and then the other one is overflow property. Now, what clip property does is it acts as a container. So they have created a container, either a rectangular container or a circular container, and then they have added some salt to that container. And then also they have made sure to hide that content if that content exceeds the boundaries of that container using overflow property. So you can see here how clip path can hide content using either a circular clip path or a rectangular clip path. The third technique we have seen is, as I said, adding comments. So not only they add comments in between base 64 characters, they also add comments between key identifiers, for example, after function names in JavaScript, or between constant strings, again in HTML smuggling cases. Now, let's talk about the prevalence, right? You may wonder, what is the prevalence of hidden text salting in spam and ham messages? Why do attackers do this? And what is the impact on existing and future email threat defense solutions? Now, what we have done is we selected a short interval, and we'll look at the frequency of using this technique in both human labeled spam and ham messages, and this is the proportion that you can see. So it suggests that this technique is being used much more frequently in spam messages than ham messages. Now, why do attackers use this technique? Well, we have identified a wide range of reasons. The main reason is to evade spam filters, but also evade any brand name identification system that you may have, or evading file analysis, right? Emails have attachments, so evading that phase of the defense pipeline. Or confusing email parsers, evading language detection, for example. And now language detection is very important in detecting email threats. That is part of the defense pipeline that is very important. So these are the major categories we have identified. Now, let's see what is the impact of this trick, this simple trick, I would say, on existing and maybe more futuristic, more advanced ML-based detection systems. I have used a few examples for each of these to show you the impact, right? So let's assume you have an enterprise email threat defense solution or an email threat detection system that relies on textual features or keywords that you extract from emails, right? And then you have an email like this that impersonates Capital One. It's a phishing email. Now, you may not see or recognize the hidden text here yet, but if you go to the next slide, you will see how they have concealed that content in the body of that message, right? So if you're relying on textual features and keywords, and then you have a rule-based detection system that relies on such features, then this simple technique could impact the efficacy of your detection system significantly. Now, if you say, I would do OCR analysis, I would render the emails in a browser or an email client, and then I would try to see if I can retrieve part of that concealed content and maybe filter that out, then this example suggests that you cannot do that, because even if you render that in an email client or browser, then that content remains hidden, so you will not be able to retrieve that content. So the impact, is still there. Now, let's assume, in addition to textual features, your detection engine also relies on HTML features. And in this example, you can see a phishing email that is a scam email, basically, that impersonate Costco brand. So if your defense solution also relies on some features that you extract from HTML directly, then this example suggests that solution could be impacted very easily as well if you don't have any mitigation options. So here you can see a long list of HTML tags that have been hidden using CSS properties. Now, what if you use more advanced systems? Many people these days talk about applying large language models for different security tasks, and most specifically for email, because that makes sense. In emails, you're dealing with natural language. So one of the areas that people are thinking about applying these models to is emails. Now, I want to raise some awareness here by reviewing a few examples here. Let's assume you have a pipeline where you use large language models to extract some features from emails, and then use those features to create a final verdict, to say whether that email is phishing or benign or legit or it's ham. So let's take sentiment of emails as one example. So I've taken this phishing email as an example that impersonates Outlook. If you look at the HTML source of this email, you can see the same technique has been used, but this time they have used a CSS type selector to hide content in this email to evade detection. Now, if you pass the whole HTML source of this email to a large language model like GPT-4o Mini and ask what the sentiment of that email is, the response or the completion you will get is neutral, right? And that makes sense because here the email suggests retain your password. You don't see any positive or negative sentiments here. Now, as an adversary, as an attacker, if you want to change that and therefore evade detection, the very easy thing you could do is add this short text at the end of that email, right? Which is also not visible, is hidden using the same CSS type selector that I explained in the previous slide. So by adding only this short sentence, you can change the sentiment of this from neutral to negative. Or if you wanted to change that to a positive sentiment, you could do it by adding this sentence, "I love this email," instead of "I hate this email." Now, this is a technique that most of the people working in security AI community know it as indirect prompt injection, right? Where people try to indirectly prompt something and then impact the efficacy of the pipeline that relies on large language models. The other example, let's say in addition to sentiment, if you use large language models to derive and extract the intent of emails and then take some action. So I have passed the same HTML source of the original message to this large language model. And the response I got was, this is a request action intent, right? Because the email suggests, please retain your password. So if you, as an attacker, if you want to change that, you just need to inject this prompt at the very end of this email, which is again also invisible. Can I schedule a quick meeting with you to discuss this further? So you can change that intent from request something to schedule a meeting, or if you want to change it to request information, you can easily do that by this prompt, right? Now, the last example is, like I said, language detection. If you pass the HTML source of that same email to the large language model, the response you will get is English. As an attacker, if you knew that, for example, Spanish emails would have a higher chance to evade detection, you can add this 2 sentences at the end of that email and then change the detected language to Spanish or to French, right? Very easily. Although most of this email is in English, but adding these 2 sentences in French or Spanish would change the response that you will get from these large language models. Now, with all these examples, let's talk about the mitigation options. Let's see what academia has done specifically, what approaches exist, and what we have done here at Cisco. So the main mitigation options you have to combat this technique is either filtering, finding and excluding the hidden content from emails, or detection, detecting when content is concealed for malicious purposes in emails, right? So these are the 2 options that is in your toolbox. Now, what academia has focused on is these 3 major categories: heuristic-based detection, detection via visual analysis, and detection via natural language processing. Now, heuristic-based approaches, they try to tap into the rendering process of the source text and analyze the rendering commands, trying to identify parts of the text that are not visible to a human reader or the recipient of that email. And those criteria could be text character, background color, font size, and things like this. The limitation of these approaches is you have no coverage for new tricks. And if you have new CSS properties introduced, or a CSS property gets deprecated, then you need to update your logic, your heuristics here. So it requires continuous updates. The next major category is detecting content concealment via visual analysis. So what these approaches do is they try to create a cognitive model of the perceived text. So they try to create a cognitive model that replicates what a human perceives, and then they have another text that is the actual text of the emails, the rendered emails that is extracted via OCR, and then they compare these two texts and trying to find visual anomalies, right? The limitation of these approaches is they have rendering errors. We know a rendering process is always error prone, and then there is a computational cost to it. The third category of approaches, they rely on natural language processing. So what they do is they try to compare the rendered text with the one that is extracted from the HTML source of emails, and then trying to find anomalies using natural language processing and some distance metric. Again, you have rendering here, and then you have OCR analysis. So both of them are error prone. They are not 100% guaranteed working all times. You have language dependency here, and then you also have computational cost. Now, what we have done is by taking all these limitations into account, we have tried to see if we can detect hidden text salting using large language models themselves. Like, why? Because first of all, it does not require message rendering. You do not require OCR analysis, which we know is an error-prone process. It scales relatively well. You don't need to use a very large model. You can use a distilled model or an optimized model. It can be applied to all messages. It can be used to detect new tricks. You don't need to update that very often, right? When you do an initial fine tuning, you don't have to update it that frequently, and then you will get high precision with minimal fine tuning overall. So I'm going to briefly explain you what we've done here. I will definitely not dive into details. I cannot explain every detail here, but this is what we've done here. What we've done is we've created a fine-tuning data set of malicious email, ham email, and gray mails that used hidden text salting technique for both legitimate and illegitimate purposes. And we have extracted HTML source from 3 different places: from the body of emails, from attachments, if they have HTML attachments, for example, or from pages, web pages, if they are pointing to a web page, extracting all those HTML sources of those pages. And then passing all these to a pre-trained model as task-specific examples. So you have prompt completion pairs that suggest these are the sources of HTML sources of, for example, body, attachment, and URL of emails that I extracted. And there was a hidden text salting technique used in these sources. Once you have this pre-trained model and you have this task-specific examples, you can instruct that LLM, fine-tune that LLM, and then later you can use it on unseen field mail flow, right, to detect whether, as a binary classifier, detect whether hidden text salting is used in any of these 3 places or attack surfaces. Now, we have filed a patent for this. It's pending. It's not published yet, but this is basically how our approach works at a very high level. And so as soon as we saw this prevalence of this technique being used in the wild, we started thinking about other areas that can help us improve the efficacy of the email threat defense solution. And one of the areas that came to mind was using features in addition to textual features or keywords. And one of them was relying on visual similarities between emails, right? So if you're interested, please take a look at this paper and work, which was, like I said, derived from the same insights. Now, let's take a look at the efficiency and performance statistics and some case studies, some examples that we could detect using the architecture I just explained. So we tested this on some data set we collected. The accuracy was 0.95, precision one was 0.91, recall 0.92, and the average processing time, it was relatively low, 2.13. The first case study I want to explain is this a great example where what you can see here, the rendered version is in English, definitely. So it's impersonating Harbor Freight. If you look at the HTML source of this email, you will see a lot of French words that have been added to this email, that they are invisible. If you look at the header of Microsoft header here, the detected language for this email was French, whereas what the recipient of this email says here is English, right? So this shows how they can use this technique to kind of confuse your language detection pipeline and therefore impact your email defense threat solution. The other one is this email impersonating PayPal. If you look at the HTML source of this email, you can see how they have hidden this sentence, "Great news, we've got your order." Now they have used a range of CSS properties, and one of them is font size, and the other one is line height. So if you change font size, if you make that bigger and remove the line height, you can reveal that added salt on the top left corner, right? As you can see here. Now, there are many ways where attackers can hide content in emails in 3 places that I explained, but these are major, or I would say the most popular properties of CSS properties that we have seen being abused to hide content in emails for malicious purposes. Text properties, visibility and display properties, and clipping and sizing properties. Text properties like color, font size, text indent, and line height. Visibility and display properties like display, opacity, and clipping is using CSS properties like clip, the older version, and most recent version, clip path or width properties. Now, you may wonder how an attacker can get these information. With all third-party services that I just explained, there's always an abusive part to those third-party platforms. If you're an attacker, you want to use this technique and you want to maximize the impact of your technique, there's this place like caniemail.com, right? So if you look at the screenshot on the left, you can enter different CSS properties and you can understand what email clients basically support those CSS properties. So as an attacker, you would like to maximize that. So you would like to use CSS properties that more email clients support, rather than using a property like clip path that most email clients do not support. Right, so there's always these, third-party platforms that can be abused for reconnaissance and for these things. Now, what are the future improvements in terms of the work we want to do in terms of scope and other use cases? Improvement, we want to definitely improve the efficacy of our approach. We want to use probably smaller, more optimized versions, distilled versions. Like I said, the model doesn't have to be very large. This is based on the initial study we've done here. We want to do further performance improvements to make our pipeline faster, and we want to study the privacy and security risks and mitigate them before using this in the field, right? And in terms of scope, we in addition to detecting hidden text salting, we want to use a similar pipeline for things like user tracking or device fingerprinting, right? Now, use cases. If you have such a pipeline for detecting hidden text salting, right? You could use it as a standalone email threat detection engine, or you could use it as an additional signal in existing detection engines that you have. If you remember, the prevalence plot that I showed you suggests that this is a very strong signal for detection. Or it could be used as an additional signal in an agentic AI defense solution. Many people talk about agentic AI, and so this could serve as an additional signal in that pipeline. Now, conclusion. To conclude this talk, I want to talk again about this double-edged sword, about the offensive and defensive use cases of large language models, right? Specifically in email security. So if you're an attacker again and you want to, use large language models offensively, and you want to hide content to evade detection or impact other stages of the defense pipeline, then you could probably find some ways to get more information from large language models and hide content, right? I do not show you the exact prompt I use, but there's always jailbreaks for that you could use to because these models do have some constraints that do not allow you to get such information. But you can always find workarounds and jailbreaks to get what you want. So I use GPT-4o mini model to see how hidden text can be introduced in the body of email, right? And you can see what great information you can get from these models themselves. I tested the same thing, but with a different prompt on other models. GPT-4o1 model, you will get relatively similar results, but probably with different granularity, different details. And you can, I did the same thing with Copilot that uses a wide range of large language models from Claude to other models. I used Claude for this example, but using a different prompt. And you can see how, easily you can get such information. Now, on the defensive side, as I explained, what we have done is use large language model for defensive purposes, for detecting this hidden text salting in emails. And so this is, again, this has both offensive and defensive purposes. Takeaways is, as I explained, HTML and CSS properties can be abused to introduce hidden text in emails. And this is a very simple and powerful technique that can impact both conventional and more advanced detection systems, and allow attackers to basically impact all stages of your defense pipeline. And therefore, developing effective detection methods and also filtering methods for hidden text salting can significantly enhance the email threat defense solutions. Well, that was it. Thank you very much for staying and listening. If you have any follow-up questions, I can probably get some questions right now, but if you have more questions, please feel free to reach out to me later.
Okay. I have some pre-made questions. So one of the ones that I was curious about when seeing this talk was, how often have you or other contacts within like an ISAC community ever seen like agentic prompts within CSS emails? Is that a technique that would be used for this sort of thing, or is it mostly just sentiment classification?
I honestly haven't seen much in the field, but yeah, to be honest, even the technique compared to other probably like CSS abuse compared to other techniques we've seen is not as frequent as, for example, brand impersonation or other techniques, but is a technique that can, although relatively simple, can impact security solutions significantly, defense solutions significantly. So I hope I answered your question, Cameron.
Sure. And I guess the other one was it's getting patented. We had talked earlier about this, about it's not necessarily, people go to these talks and they're able to present on techniques because they want other people to learn about them, I guess. Can you explain more about like the approval process to be able to talk at one of these things, to be able to say like details about the secret sauce, but without saying what the patent is, I guess?
Yes. So when you say you have a patent, you definitely when you're working in an industry, you can't get into details that much. As you notice, I just proposed the very, very high level of how our approach works. There are a lot of details into it, both in the way you create your data set, the way you fine tune your model. So there's a ton of details that I didn't explain. The idea is to kind of foster research in the same domain, kind of trigger others to think about the same problem and maybe come up with similar or different approaches. So that's totally fine.
Awesome. So I don't see any questions in the stream. So if that's everything, then I'm going to go talk about the next talk. So, all right. This week we do have 2 presentations. So, and the next one is also going to be from Cisco Talos. It'll be with Taryn Valakodith, Analysis Without Paralysis, Mastering the Art of Investigation. This one that we just barely had was a bit of an advanced talk, is in the advanced track. And this next one, it looks like it might be a little bit easier. If this one was very confusing right out of the gate, the next one will be, I think both of them are both amazing talks. So, all right. Thank you all for tuning in. And thank you so much, Omid, for being here. So
thank you.